Okay, so this is the solutions to the feedback quiz with my comments. Obviously, you can just look at the answers if you're interested in that, but I thought I'd add in a couple more things. Um, this is what we've done before. It's like sometimes you're given a problem with the statistics and you have to calculate the equation of the line. So using R, Sy, Sx, you can calculate the slope right here. And sorry, that's all messy, but it's 0.43. Once you find that, you can use X bar and Y bar as a point on your line to find your y-intercept. So once you have that, you write it all out. One thing I do want to point out is that this has the hat on it, the width, because that's what you're predicting. And then the height does not have a hat on it. And a lot of times we don't really use X and Y. We just kind of write in the word, like write in what it is. It's just a little easier to understand. It takes care of the context for you. You don't have to explain what X and Y are if you just put in width and height right in there. Yeah, the only thing I wanted to mention here was that just remember that R is a slope, but it's in terms of z-scores. And when you multiply by the rise over the run with standard deviations, right, you're using these numbers. You're just changing something that's unitless, the R value, into something that has its units back on it, into a slope that has units, right? So S of Y and S of X units. Number two, R squared, R squared. This sentence we need to memorize. 60% of the variation in study hours can be explained by the association with caffeine intake. It's always the same thing. Whatever R squared is, you start off with that percentage. The variation in those Y values, right? So this is the Y value always. Y units, I should say, are the context. So 60% of the variation in Y can be explained by the association with, and then this is your X, whatever X is. And in this case, it's caffeine intake. You don't need any of this other stuff. You just need the R square. That's all you're talking about. So when it says interpret, right, that's what it's talking about. We want specifically this sentence. It's something that should be just like that. No variations really on it. We'll talk more about like what does that mean, right? In my next video, the lesson video, I'll explain that. So you should watch that next. Which is not a condition for being able to use a linear regression model. Yeah, this correlation. It doesn't matter what R is. You can always do correlation or do an equation of a line, no matter what the correlation is. It might not be a strong correlation or it might not be a strong association, but you can do it anyway. The residual plot always has to be evenly distributed. It shouldn't. That kind of shows you that your data is linear. There can't be any fanning. There's reasons for that when we get to inference. I'll explain that later. We want it to be consistent throughout. Can't be curved, blah, blah, blah. Residual plot must look like, yeah. All those are kind of saying the same thing. But we don't really care what R is. You can, if R is, big or small or whatever, you can still do the regression. Okay, number 4, influential points. You notice, like you remember we talked about R values being calculated by the ZX times ZY, and you get a rectangle for each one. So it's true that a point that's further away will have a bigger area and will have a bigger effect on the R value. So you can see like this point B right here has a big effect. That's very true. It has a big rectangle. But what they're talking about when they say influential is a point that is not in line with all the other points. So it is changing the slope because it's so far away and not in line. So this point E down here, it's like leverage, right? This thing is so far away from the center that it has a lot of leverage. B has a leverage too, but B is not going to change the slope because the slope kind of goes right up through here anyway, really close to B. So E has more influence because it's going to take this slope and it's going to pull it down towards E. It's going to change the slope of your regression model. So we say that's going to be even more influential than point B would have been. I hope that makes sense because, yeah, it's all about like how big of a change is it making to your slopes and stuff. So E really should be the answer on this. Yes, B is influential, but E is even more influential. Okay, that's it.